Alexa stack. It's a sort of productized feature stack, maybe more than a technical stack. But you have the Alexa platform, which is kind of the cloud service, and the devices, because some stuff is kind of dependent on the actual devices. And then roughly the functionality on Alexa is, I would group it into 3 separate things. So we have skills. You have, which we'll come back to skills in a minute. You have the media functions, so that's your things like TuneIn, Spotify, Pandora Radio, Amazon Music, all the different music services that can use it. So the most popular thing people buy an Echo for these days is they just use it as a posh speaker at home to play Spotify on. Over on the right, you also have a growing but slightly disjointed comms stack within Alexa. So there is Alexa calling, if anybody's ever used that, and if anybody wants to see and talk about that later. You can make calls between Echo devices. You can drop in, which is a subset of calling, where you can kind of auto-answer. And there's some Amazon, so they've built their own calling. There is Skype built into these devices now, so you can auth it to your Skype account, and if somebody calls me on Skype, if anybody still uses Skype, my Echo will ring. And there is some PSTN phone functionality. There's a really interesting thing they did the other week in the UK, actually, with Vodafone. You can now link your Vodafone mobile to your Amazon account, and if somebody calls your mobile, your Echo can ring. So your mobile calls over the IMS links out to the Echo, and also you can make calls out on your Vodafone mobile. But going back to the skills, so this is really where most of the development and the stuff we know today happens. Oh, and that's James calling me on Skype.
We'd like to talk.
There's always one, isn't there?
Hang up!
Shouldn't have said that you could do that. Somebody else said. So in the skills stack, roughly skills are organized into 3 types of skills. We have custom skills. This is probably what most people know of. This is things like Domino's Pizza. So this is the kind of the app store where Domino's can build a custom skill, put it on the Alexa platform, and you can say, Alexa, tell Domino's Pizza to order my usual. And half an hour later, the nice pizza man turns up. We have smart home skills. So smart home is, I think, a really interesting use case. I have a really wide smart home with like Hue bulbs and all kinds of crazy things and doorbells and sensors and stuff like that. So smart home functionality is another part of skills, and you can people like Philips and that kind of thing, and all the Chinese IoT manufacturers are building smart home functionality. And then there's flash briefings, which is basically just like a way to drop an RSS feed with a bit of content in, and so somebody can like get their regular, it's a content subscription skill, but they call that skills. So the WebRTC stack is actually in the smart home functionality. So this is the interesting thing. It's not part of comms. So those of you that are hoping, hey, great, we can now start building all our WebRTC conferencing into the Echo, I have bad news for you. It's in smart home. But as a renowned abuser of hardware, I didn't think that should stop me. So this kind of started out with me trying to figure out how can I make Alexa do phone calls for a customer. So really, the reason the WebRTC stack is here is for this. So loads and loads of smart home cameras. So we've got the Ring doorbell, which some of you guys are probably familiar with. So I have a couple of those at home. This is I can't remember what it is, a Wise Cam. I think it's a cheapy camera that supported it. The Blink cameras, which are now owned by Amazon as well. The Arlo cameras. All these different home security cameras have connectivity into Alexa. So you can bring up the camera on the screen of your device. And these are the current Echo devices that have screens. So on the right here, we've got this side, we've got the brand new Show 5, which I think James has got one with him, but mine's still shipping somewhere. The first gen Show that they produced, which was a sort of 7-inch screen and very square, I think. This is the second gen Show, which is the one we've got down here, the 10-inch screen. And there's a tiny little Spot as well with a round screen, which I've got one, if anyone wants to have a look, upstairs. But and yeah, round screens, really not fun if you're trying to design visual interfaces on a circular display. That was not popular. Okay, so what can you do? We said bearing in mind this is designed for cameras and doorbells. This is not designed for comms. So video is only one way. You're going to get video from the device, in that case the camera, the Ring doorbell, to the Echo. So you can send video to the screen of the Echo. But this has a camera in the top here. You can't access that yet within the WebRTC. So you can't get video from the Echo device, which is already a bit of a bummer. But you can do 2-way audio. So again, think about the Ring doorbell. someone presses your Ring doorbell, you say, Alexa, show me the front door. I can see the person there, and I can talk to them because the Ring doorbell is a camera with no screen and two-way audio. So very much, and most of the security cameras, again, I can use the Amazon Cloud cams in my house and press the button on the app and talk to the dogs and things, because my house is wired with cameras basically to watch my dogs, by the way. I'm not like some weird dystopian thing. Or at least that's what I tell my wife. So, how do we do this? There's 4 things we need to build, and I'm going to go into some of the, very briefly, how to build. All the code for this I'm going to put up on GitHub when I clean it up, maybe next week or 2. But we have to build a smart home skill. We have to set up account linking. We then have to go through device discovery, and then we can get on to the session creation, actually making a call. So, I'll whiz through very quickly. Smart home skills. This is basically a bunch of config on the Alexa developer portal. So you go to developer.amazon.com, say I want to create a new skill, it's a smart home skill, give it a name, and you give it a few different attributes. Has anybody ever built an Alexa skill here before? So you're familiar with building the voice model? You've got to build train it to say what your intent is. You know, Alexa, order me a pizza is my order pizza intent, and there's that piece. With smart home skills, there is no voice model, or rather it's predefined by Amazon. So what you can say to trigger the events is all set up for you. Again, that makes it's great for smart home, it makes it easy to build a skill. It's not so great if you're trying to do weird things with this. One of the other interesting limitations of smart home is the endpoint has to be a Lambda function. Now, if you built a custom skill, Lambda is Amazon's serverless function hosting, so you can put a bundle of Node or Python or Java or a few other languages, I think now, onto Amazon, and they just execute the function. And Alexa can be used as a trigger for that function. Normally, when you're building a regular skill, you can host that on an HTTPS endpoint, and Alexa will make a call to that. For some reason, with smart home, it always has to go through Lambda, which isn't a huge issue, but we get around that. And the other one is you have to do account linking. So account linking is basically OAuth. When I set up my device, or I set up the skill, it says, okay, you have to log in to your smart home device. I have to link to my Hue account or my Ring account or my whatever account. I can't just say, here's a skill and there's no. So as part of the installation of the skill for the user, they have to go through an OAuth process. So again, it's just a bit of overhead really to building all of this. This was my Christmas hacking project basically. This is what the smart home portal looks like. So it's a web interface, and you just set up a few things. You tell it the Lambda ARNs. There's different ones for different regions, but that's only if you're using notifications. And you set up the account linking, like putting in the OAuth parameters. Then we have our Lambda function. So this is my Lambda function. With this one is written in Python. Really, all we're doing is we get these various events at the top here, and I pass those off to a different little function. The Lambda function itself is mostly fairly dumb. I've written it as a proxy. So all that happens is the event comes into the Lambda function, and you could see down here in the code, if I expanded it, it just makes an HTTP request to my actual server. So I've hacked the requirement to use Lambda to say, yeah, Lambda received the request, forward it onto this HTTP server, and send back the response. So it's acting like a bridge. But we've got a few different events at the top here. So we get the Alexa.discovery event, which we need to respond to with the device discovery, the authorization, and then the other ones are the session controller stuff, which we'll come on to. So yeah, account linking required. It uses OAuth. Amazon actually have an OAuth provider called Login with Amazon. Obviously, anybody that's going to have an Echo will have an Amazon account, so I use that. And I've just stubbed back the response, so I don't really care what you've authed to for this purposes of this skill. You can log in with any Amazon account and access the camera. It's a proof of concept. Like this is what account linking looks like. So this is the Alexa app that you would have on your phone. Once you've installed the skill, you have to go through a kind of marketplace and say, yep, enable the skill. It then prompts you for an OAuth process. You put in your Amazon credentials or any Amazon credentials, and it says, yep, great, it's been linked, and gives you back a token in the skill, which if you want to then, you would normally associate that with the camera that's owned by the same account. So the principle would be in a production thing that I need to, when I set up my camera, I need to OAuth that camera to an account, the Amazon account, and then I need to OAuth the skill to it, and then when a request comes in to invoke a session, I can look up to the to check the camera is owned by the right user. And yeah, the account linking, this is the function we're handling in Lambda. So all I'm doing is getting the request in. I'm firing it off to this ngrok, to my local server, just so I see it, but I'm not really doing anything with it. And I'm just responding with an OK. Yeah, that's why I'm kind of stubbing out the response to say, yeah, you're sending me an Alexa authorization. I'm sending you an accept grant response. Fine, whatever, ACK. And it'll go, OK, yep, your account linked. And I'll send you the token every time. Some water. OK, the next piece we have is device discovery. So again, this is the first time you set up your device. Alexa needs to find your smart home devices. So you can either say Alexa discover devices and it'll run, so any linked skills it will then make a discovery request to, or this is kind of prompt after you've done account linking. So this goes through, this is the Alexa app again on the phone, and it's discovered one new camera, and you can see the name of the camera over on the right hand side there. It's called RTC camera for this project because it was fairly basic, and a bit of descriptions and what it is. So we have our device discovery, and again, this is the more interesting stuff. We'll get into the Alexa thing. So this is the response that you need to send back to a discovery request to your skill to say, hey, yes, this is a camera. So the main stuff, let's do it without one over here, really, so this is the header piece. This is the details of the camera. So the endpoint ID, you just make up a serial number of your product or whatever, so it's browser 001. Manufacturer name, the internet's. You'll see why I did that in a minute. Model name, stuff for you. A description, it's a web browser with WebRTC, and the categories of what it supports. So this is kind of important. So there's the two features here is I'm supporting, it's a camera and it's a doorbell. I'm not going to show you the doorbell stuff in this presentation because I ran out of time, but the doorbell is basically a way to send a notification to your Echo to make it ring and say, hey, there's somebody at the front door. So there's once you've authorized all of this, you get an endpoint that you can make a request to, and it'll make the linked Echo play a doorbell sound, which is as near as you can get to calling somebody. And then there's two interfaces we're defining. One is it supports the RTC session controller interface. It's a WebRTC enabled camera, and the other one is it's a doorbell interface, or it's a doorbell event source. So this is this endpoint. Cool. So session creation. This is stolen from the Amazon developer docs. So where you get Alexa sends when somebody says, you know, show me the front door camera or whatever, Alexa will send this initiate session with offer directive. So that is a request with payload, and it contains some SDP with an offer in it. So now we're starting to see some WebRTC. And the 3P, this is your third-party device, or you as the smart home provider. And you think, okay, that's great. You send me an offer, I send you back an answer, and it'll send me a session connected to say, you know, okay, and we're in a session. Easy. I thought, this looks simple. Right, I can just, you know, I just need to take that offer and send it to the thing. However, this interface here between Alexa and the third party is HTTP. Regular REST HTTP, no WebSockets. So anybody that's ever done anything with WebRTC and signaling, how do we do the signaling server? Nearly always, oh yeah, we'll use WebSockets. We'll connect, we'll get a WebSocket from our browser, and we'll send our messages over the WebSocket. But Amazon doesn't support WebSockets for this interface. So this was a bit of a blocker, especially because I wanted to try and connect it to a web browser. And a web browser definitely, you know, if I've been doing this with a Raspberry Pi or something, it's like, okay, I can expose a HTTP server on the Raspberry Pi, and I can tunnel that back out somewhere to the internet, and I can make Amazon send the HTTP requests to the Raspberry Pi and things. But I can't make an HTTP request to a browser. So what we have is Alexa sends the HTTP post, my web browser over here. How do I get that there? I've got two clients that can't talk to each other. So we need a server. I need to build my own server in the middle that acts as a signaling bridge. So what we do is, the order here, when you first open up the web browser, we're going to connect our WebSocket when the camera logs in, and we're going to sit there on a WebSocket connection. The HTTP post is going to come in. I'm then going to take that offer out of that post, stuff it in a WebSocket message, send it down to the web browser, and the web browser can send back an answer. Relatively easy so far, yeah? We just have to do a bit of HTTP to WebSocket sort of mangling. there's one other problem with this. If you look over here, the post is in, the HTTP request contains the offer, and the HTTP response, it expects to contain the answer. So really, these sort of round trip times here, and this is, I believe, limited to 3 seconds. If Alexa doesn't get a response to the HTTP request within 3 seconds, it'll abandon the session. So I've got to come back with my answer within 3 seconds, including the ICE candidates, because you only get one message back. So normally, you send an offer, and then we do trickle ICE, and we send various ICE candidates, and then the answer is set up. So usually you have several messages going back and forward. So the other thing I had to do was, we have to, before we send the answer, we have to make sure we've got all our ICE candidates, or we've got at least enough ICE candidates, and those actually have to be inside the answer SDP. It doesn't support trickle ICE. Which, again, was a bit of a, oh shit, okay, that's more complicated moment. So now we get the offer in, we gather ICE candidates, because you can't do ICE, or at least I found it, I couldn't find a way to do to gather ICE candidates before I had an offer. So I have to gather the ICE candidates, and then at some point in the browser I make a decision to say, okay, now respond back on the WebSocket with a new WebSocket message with my answer containing my ICE candidates, and send it back to Alexa, and hopefully everything will line up. So this is the web server piece of code, and now we're in Node because I was having one of those schizophrenic days when I was writing some stuff in Python and some stuff in Node, just because I couldn't figure out how to do it in one or the other language. We've got 2 handlers. This is the /skill. This is the web server that talks to Alexa, and this is our WebSocket handler. So basically what happens is WebSocket just comes in, binds in, and on a message, when I get a message from the WebSocket, I just set it to a variable called answer. This is very, very crude, hacky code here. The skill handler, a post request is made to /skill, and I'm looking here. Basically, I create my offer. I have to do a little bit of manipulation because the request Alexa sends me isn't an offer as such with type offer. It has something else in there. The format is slightly different, so I just had to manipulate the JSON a little bit to have the format the browser was expecting, not the format Amazon are sending, because they've invented their own thing again. Send that down over the WebSocket, and then basically I just set a 2-second timeout in my code. So I wait 2 seconds, and then I will send back the response as to whatever the answer message is, by which time this answer should have been set by the browser sending back another WebSocket message. So very crude, very unscalable. This works for like 1 camera and stuff like that, but you know, it was a proof of concept. Okay, let's try. Sorry?
I have a suggestion.
On the code?
Yeah, no, on the slide before. Yeah, so why wouldn't you create an offer right when you connect on the WebSocket and let the web server resolve the offer answer locally, so that, because the candidates that exist in the browser, they can be gathered all the time.
You could basically create the offer from the browser, gather all the candidates ahead of time. And if you want
the answer, no, I have to send, because I have to have an offer from the Alexa service in order to build the answer.
So one of the things that you could do is you could gather everything, get an offer.
So create like a fake offer.
Yeah, create an offer from the browser, resolve the offer answer in the web browser, and send the answer and the offer.
So they're ready.
No, if you, right, so you can do the pre-answer, but if you want to look at example code, go look at WebRTC.
Okay, yeah. Well, we'll talk about it later, but that's yeah. Let's try this demo. So the other problem I found was that this worked reasonably well over like home Wi-Fi, and somebody in our office tried it and things. Could not get it to work on the Wi-Fi here. It turns out not the Echo side that was the problem, but it was the web browser side. So what I've done as a bit of a hack is, this is the web browser page is currently running. So the server is actually running on my laptop with ngrok. The browser this is running in is Chrome on my iMac and my desk in my office at home. So what we should do is when we connect to here, we'll connect to the webcam on my iMac, and you guys will all see my office. And there might be dogs running around. But hopefully, Alexa, show me the RTC camera.
Okay.
So this is the waiting.
RTC camera is not responding.
The server failed. Demo fail. Right, what happened? WebSocket. Looks like that's interesting. It looks like the WebSocket died from the browser. WebSocket connected. Ngoc's there. Okay, it's doing some stuff. The page. Let's try again. Alexa, open the RTC camera.
Sorry, I didn't find a device named Office C. Camera.
Alexa, open the RTC camera.
RTC camera doesn't support
Oh,
that.
not open, sorry. Alexa, show me the RTC camera.
Okay.
It's quite, that's what's about the voice model being quite picky, but this should. Yes, and that is a WebRTC session. So that is my mess of an office. There's a dog bed there, and we can actually, if we turn the mic on, we've got the mic is disabled by default. We say, Grimble. See if I can get a dog out of bed to come in. I expect my wife may have shut the door actually, but yep, you will have to trust me. That is a live WebRTC session between Chrome running on my iMac at home and an Echo. So, very cool. Alexa, stop. There we go. It's gone. Put safety back on. So it's a little bit jury rigged. Let's let's go back and have a quick look at some of the code as to what I was doing. So this is the code that's running in the browser. So we start off on click, or actually it's now just on ready when the page opens. We connect the WebSocket and we define a handler to, when we get a message, handle that answer offer. So when the WebSocket opens, we create a peer connection and we set up a couple of handlers for ICE candidates and gathering state change. And then, yeah, on open for the WebSocket, we run this function local media, which is also the second one. So sorry, yeah. WebSocket is connected. When the WebSocket declares itself as open, I run these two functions, which are here. So this is what's calling this function. This is how I tried to notate some code on a slide. So we do this RTC setup, where we set up a peer connection and we define some other handlers for events, and then we also get the local media just so you see the camera. Then when a message comes in, so when that message is sent down to the WebSocket, this is how we're parsing the message as our signaling for the offer. Sorry, RTC set description, create an answer, and build all of that, and we basically build our answer. Then what we're doing is ICE candidates are coming in. I'm just logging the ICE candidates here. The key thing, so there's two things. The other thing I'm doing here is I'm setting a timeout. That was it. So I'm setting an answer timeout to send the answer after 2 seconds. So even if I'm still gathering ICE candidates, at 2 seconds I'm just going to go for it and say, yep, send the answer with whatever ICE candidates you've got, because we can't wait any longer. Turns out generally all the tests is always been quite quick, but equally when the on ICE gathering state change occurs, so if it actually says, okay, gathering state is complete, I'll then bin the timeout and send the answer anyway. So either the answer will come back once ICE gathering state sets to complete, or after 2 seconds, whichever is first. And yeah, on track, we're just adding the streams in when we get the tracks. This is what the offer looks like for those of you that are into looking at SDP. You'll see the only really few interesting things. So the audio is Opus, the video is H.264, which supposedly should be supported in Firefox, but I couldn't get the video to work in Firefox, and I tried it again the other night, and it still wasn't. So it's only was working in Chrome. But again, this is really crude WebRTC code that I've written on the server, so I haven't done stuff. The most interesting thing to me was these are the IPs for the Echo, for Alexa's endpoint, the ICE candidates. You never see the local IP of the Echo. You'll only see in that offer Amazon IP addresses. These are some addresses in AWS. So I'm not sure whether they're just forcing everything to turn, and whether this is a turn server possibly, or if they're doing something else, and actually you're not really doing WebRTC from here. This is doing video. This is some Amazon protocol that they're proxying out through the cloud. But basically, as far as I'm concerned, when I'm talking to the Alexa endpoint, I'm not talking as a developer to this hardware on whatever network it's on. I'm talking to some endpoint in Amazon. And those IPs change quite a lot. There's obviously a big cluster of servers. Video media. The other one that was quite interesting to me was that this is actually, in the offer, contains video. But it's one-way video. I don't know if somebody knows. So that's implying that this has a camera here, isn't it? Because it's not just it's offering up video, but there is no video track ever sent. So is that a future capability? Is there something there? Have they just forgotten to like disable it? And I haven't really sort of pulled apart the media to see what might be in that video track. And this is my answer going back. This is actually one I created in the hotel room last night. So we've got the ICE candidates. That's the IPs of the hotel LAN, and all fairly crude, sort of auto-generated stuff. Cool. Thank you.
Okay, question time. Looking around. Well, I've got one to kick off. Have you documented all the stuff online yet?
No, I'm going to put all of the code I'm going to put up in a GitHub repo for building this, and that's usually as far as I get with documentation. I'll put some stuff in a README. The talk will be online. Ask me. This was so this actually started out, I didn't say, as kind of an interesting challenge. A friend of mine runs an Alexa consultancy, and he asked me back before Christmas. He wanted a way. He had a customer that they want to connect. They want to give the customers echoes, but they want to connect to live contact center agents. Was the original challenge for this. So it's like, Alexa, I need technical support, and she guides you through a few basic things, and then goes, okay, I need to connect you to an agent. How can we transfer somebody who's talking to an Alexa skill to talking to a human being seamlessly? And it turns out you can't really, but I basically spent a lot of time exploring the various communication functions within Alexa, including the WebRTC stuff, to kind of see, is there something I can abuse? What you saw there was the biggest problem was that voice model. I have to say, Alexa, show me the RTC camera. I can change what it's called. So I can say, Alexa, show me the technical support agent, but I can't like choose to control the voice interaction, so it's not very good for that.
Yet.
Well, yeah.
On that voice model thing, say it's a dumb doorbell that's audio only, no video. You still have to say show instead of here?
You can say, I think we can say, so we can't say open, that's one of those. We can say connect me, I think. Alexa, connect me to the front door.
Searching.
So what connect
I
means?
don't see anything to connect. Check
No,
the
that's trying to,
use.
Bluetooth, yeah. I think you've got, you can say answer. Alexa, answer the front door. This is my Ring camera on the front of my house, so we could say answer, because normally that would be if you've got a doorbell event. And yeah, that's my Ring camera on my front door, and there's nobody at home yet, so you might see a postman in a bit. Alexa, stop. But you've got limited voice commands, which is really that's the thing that limits you abusing this for other purposes. If we could, within the concept of our own custom skill, invoke smart home, which is there is some sort of extended merge stuff, but it's not quite there. There is also the calling features as well, but next one.
Is there any limit on the duration of these WebRTC calls to the device, or does it like time out after a minute, or can you just leave it up?
No, I haven't seen anything. I haven't tried it, but I've had a session open for. In fact, I did once leave. I'm not sure it was WebRTC because the Ring. There is another camera handler. There's an RTSP legacy stuff which some of the cameras use. I think the Ring is using WebRTC though because they added the mic stuff. And I had left my Office Echo Show on my desk connected to the Ring camera on the back of my house overnight once. I came in the next morning and thought, what's that noise? And realised it was still showing my external security camera.
Great,
so,
thank you.
Nothing practical.
Any more? Let's talk very quickly about use cases whilst I'm walking over here. This sort of thing is particularly well suited for use cases which involve mother-in-laws. Do you want to just say 30 seconds about that?
Oh, well, yes, my primary, my mother, you mean? Not my mother-in-law. It's my mum, yeah. So, yeah, no, the calling feature, everyone needs to decide who uses drop-in and things. I use Alexa drop-in calling daily. My mum lives in an annex part of our house. She's a little little granny bungalow attached to the back of our house and comes over for dinner every night. So she has an Echo, or there's a couple of them actually. She has one in the lounge, or she's sitting watching telly. I have a spot in the kitchen, and I just say, Alexa, drop in on Mum, and 2 seconds later I just get bing bong, and we're connected in an intercom, in an audio channel. There's no answering or anything, and I just say, hey, dinner's ready in 5 minutes, and she can say, okay, coming back. And she actually, this was about a year ago, she even asked me once. She said, if I fell over in the night going to the bathroom or something, would Alexa in the lounge hear me if I said, Alexa, call Sam? Would she be able to call you like an alarm thing? And we sort of thought, well, if you're on the bathroom floor, like, in the bedroom, the Echo's in the lounge, maybe, maybe not. And she said, well, can we get another one? So she now has a spot in the corner of her bedroom, purely used for reassurance, so that if she falls or something, she can call me. So, it's, yeah.
It was just a really quick idle question about that one-way video feed. I wondered if you'd had chance to sniff what's going on the wire at the Alexa end to figure out if they're doing something evil, like sending the video to the media proxy, so that you've actually got the Alexa sending video and they're not passing the track through.
I haven't. I mean, to be honest, it's all going to be TLS, and
yeah, but you'd see from the payload whether you'd got a payload.
Yeah, and the problem
just
is
the size of the
so
payload.
Much, yeah. I mean, you could probably tell if there was video, couldn't you? I mean, because obviously there's audio potentially. Although you've got like there's actually 2 different ways it can connect, depending on whether you say, I think, answer the front door, show me the front door, whether it enables the mic by default, or whether you have to touch the little thing. There's also a half duplex push to talk mode. Yeah, it'd be interesting to see how much media is going from, when I'm in a session, how much media is going from the Echo up to Amazon, and are they actually streaming my camera? But yeah, no, all of the Echoes have cameras. The Show 5 has actually got a little physical switch they've added to switch the camera off. Although, interestingly, when you have it on this mute mode, where, or I call it the safety catch, where I can say, Alexa, 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 and she won't trigger. If somebody tries to drop in on you, the video is also disabled, so that you can't drop in if you've got... It's not great to me, because I might want to hide the video, but not the thing. Or you just get one of those little webcam covers to put over it. So.
Okay. Any more? Well, I thought that was
if anybody wants to see
yeah.
other Alexa calling stuff or play with this, I discovered a really interesting thing with the Echo Connect by accident this morning as well. In fact, I'll show you one last thing. The Echo Connect is a little device Amazon sell for £20, £30, depending on how much they feel like charging you, which is a bit like an ATA, the SIP ATAs that used to plug in.
analog telephone adapter.
Yeah. It's one of those, but for Alexa, because it allows you to plug your Echo into your home phone. They really are aiming this, I think, at the older market. But I've thought, okay, that's great. I can plug it into a PSTN analog phone line, or I could plug it into another ATA, which is plugged into my Asterisk PBX. So I have an ATA plugged in at home to an Echo Connect plugged into Asterisk. So I can, for example, now make a call that will, and I assume this only works like over the local LAN. But if I do, Alexa, dial 9600.
9607.
Damn. Let's try again. Alexa, dial 9600.
9607.
Really?
This is noisy.
Alexa, dial 9600. Yes, there we go. That's calling an extension on my Asterisk, which will all recognize. That's quite cool, because actually I didn't realize that would work remotely. This is logged into my Amazon account, but the Echo Connect is just sat on my LAN at home. And this is setting up I think a SIP call between here and this little bridge at home and going out on my phone line. And we can actually see the latency in a minute. Alexa? Oh, stop. Oh, that's it. That's the end of the call. And that's the end of the call. But yeah, so that was making, so you can, and that's kind of interesting that you can stick an Echo Connect anywhere on the internet that's paired to the device, and it will actually make calls through it.
Yeah. And if you,
that's got more potential for abuse.
For those of you who didn't know, you can actually just make free phone calls on this.
Yes.
So you just say a word, call, followed by a telephone number.
I can't do that because I've got it always falls back to the Echo Connect.
Oh.
That's what I just. That's what I was trying
Well,
to do it last night, and then
That's
yeah,
the
and then I went-
problem with being
That's having the Echo Connect on the device.
yeah,
But yeah. Anyway,
too advanced. But anyway, thank you, Sam. You're absolutely smack on time.
was that you just sent me that message on?
Yeah, I just wanted to see whether it would come up on here.
Yeah, message from Sam. So James sent me a text message through it, and it came to on my watch.
It's also,
Sam Machin from James Body. Brilliant presentation, Sam. You have just planted seeds that will undoubtedly result in huge levels of extreme Alexa hacking. Received just now.
Alexa, reply.
What's the message?
Thank you, James.
Got it. Should I send it?
Yes,
Sending.
that's the built-in messaging
there we are.
functions. Yeah, as part of the calling again, you got messaging. So.
yeah, you see what really super useful devices these Alexas are. So you're going to rush out, if you haven't got one, to go and buy half a dozen.
I've only got one in this room with me right now. But
Well, I've got a couple with me as it happens, and
Cool.
and I've got a couple of cameras as well. So
think
perhaps
it's-
later.
yes, we can.
Yeah, do you want to moderate yourself now?
I'll do this. I've got the
Okay,
mic.
right, go for it.
Okay, so that's it. It's lunchtime. We're back at 1:30, I believe. Or it's on the schedule. Thank you.